Our gaze extends to the night sky and reaches the vastness of the universe. But if what we see, this vast array of stars, constellations, and distant objects, is only part of a real universe, it cannot be expected. Science says that our view of the most important things is limited, the world we see and study is only a fraction of the whole world. However, recent discoveries suggest that there is something more beyond the visible horizon, something we are dealing with right now. What could it be? Could there be another world, hidden behind a veil of cosmic mystery, that holds the power to extend beyond space? And what does the Earth have to do with this planetary drama? This is not science fiction fantasy, but the very latest scientific thinking. We now know that the Earth is at the center of something bigger than we thought. And what lies beyond, well, that remains the most intriguing mystery of all. For a deep dive into the hidden forces of the universe, there are the boundaries of space and time, the nature of distant galaxies that defy explanation, and where the universe can be viewed from the wider world and come closer to ours. With each passing dive, our understanding of the universe is limited by natural phenomena, especially the speed of light and the expansion of space. What we see, the so-called visible universe, is defined by how far light could have traveled since the Big Bang. At first glance, we can assume that the distance we can see is 13.8 billion light-years away, which is equal to the age of the universe. But it is not like that. Due to the vastness of the universe, our universe is far beyond the visible region, about 46.3 billion light-years. This optical domain means that everything we see in the universe is ancient. When we study distant galaxies, we see them billions of years ago. The light we see today from these distant objects appeared long before the existence of man, even the Earth itself. Therefore, we do not see the state of the world, but the state of historical events. This universal time machine can look back, but it also raises a deeper question: what lies beyond the limits of what we can see? The thought of something beyond the visible world is both haunting and terrifying. If the universe is truly infinite, then there is an abundance of matter and energy beyond what we can see. And if the universe is expanding, as most scientists believe, there is a region in space that will travel faster than the speed of light and will be inaccessible. However, these hidden areas may not be obvious. New evidence suggests that there may be something out there, a powerful gravitational field that extends into the visible universe and pulls galaxies there. But first we need to understand why the Earth is called the center of the visible world. This is not a return to the long-discredited geographical view of the world, which placed the Earth at the true center of the universe. Instead, Father occupies a central place because no matter where the observer is in the world, he is always at the center of the visible world. This is a result of the isotropic nature of space. The universe looks the same in all directions, no matter where you are. So, from our perspective on Earth, we are in the middle of a celestial bubble that stretches 46.3 billion light-years in all directions. Inside this bubble, the universe is full of galaxies, stars, and nebulae. But beyond that, there are places we can't observe directly. This hidden world is a source of great speculation among astrologers and astrologers. The first hint that something was lurking beyond our view came in the early 2000s when scientists studying the cosmic microwave background, CMB, noticed the flare of the Big Bang, a strange pattern of movement of distant galaxy clusters. According to the standard model of cosmology, galaxy clusters should move in random directions relative to the CMB. However, data from NASA's Wilkinson Microwave Anisotropy Probe, WMAP, revealed something very surprising. Many galaxy clusters are moving in the same direction, as if pulled by an invisible force. This phenomenon, known as the dark current, defied explanation. The movement of the galaxy clusters became stronger and faster with distance, indicating that they were influenced by something beyond the visible universe. The discovery of the dark current has raised many questions. What is the strength of the argument? Could a vast structure, perhaps another world, lie beyond our line of sight? The concept of the dark river refers to the image of a mysterious giant, a powerful art that darkens everything in our visible world. The idea that there might be other universes, each with its own set of physical laws, has been explored in various scientific theories. One such theory is the concept of the multiverse, which suggests that our universe is just one of many, each occupying its own bubble in a larger cosmic sea. According to this theory, each bubble universe could have different properties, with some being completely inhospitable to life, while others might be similar to our own. The dark flow could be evidence of another universe, one whose gravitational pull extends into our own, tugging at galaxies across the cosmic divide. Alternatively, some scientists believe that the dark flow could be caused by a massive structure within our own universe, but one that lies beyond the observable limit. This structure, possibly a large cluster of galaxies, can exert a strong force on nearby galaxies, pulling them in. However, this theory has met with skepticism, as it would take a lot of mass to produce such a powerful effect, and there is no evidence for such a structure in the observable universe. Despite these uncertainties, the existence of dark currents has not been completely ruled out. In fact, subsequent research has provided more evidence to prove its existence. In 2010, researchers found that the number of galaxy clusters associated with the dark stream doubled from 700 to 1,400. This increase in the number of infected clusters indicates that the dark current is not a statistical error but a real phenomenon. If a dark stream is formed by extraterrestrial gravity, it will be discovered, and it will have profound implications for our understanding of the universe. It means that the world is much bigger and more complex than we think. There may not be a point in space that we cannot observe, no matter how advanced our technology. Some scientists believe that the dark stream is caused by the influence of a parallel universe. According to this theory, our world is just one of many worlds, each of which lives in its own heat, in a higher space. When the two particles collide, they can create a new universe, just like the Big Bang that created our universe. A dark stream may be the result of an interaction between our galaxy and another, pulling galaxies to the edge of the visible universe. This idea is supported by the theory of cosmic inflation, which suggests that the universe evolved at a rapid rate during the time after the Big Bang. In this expansion, the areas of space are separated from each other and create separate worlds. These worlds may not be visible to us, but their influence is still felt. The multiverse theory is also supported by string theory, which suggests that there are more dimensions beyond the 3 dimensions of space that we see. According to string theory, gravity is the only force that can move between these dimensions, which may explain why nature is so weak compared to other forces in nature. If it is due to a cosmic interaction between our world and another world, that is proof of the existence of these hidden dimensions. Despite compelling evidence, the idea of a dark current is still controversial. Defenders argue that this phenomenon can be explained by more common reasons such as errors in the data or the influence of precognitive global structures. For example, some scientists have suggested that the movement of galaxy clusters is caused by large changes in the distribution of matter in the universe, rather than by forces seen outside the universe. In 2013, data from the European Space Agency's Planck satellite disproved the existence of a dark stream. The Planck satellite, designed to study the CMB in greater detail than WMAP, found no evidence of the massive movement of galaxy clusters seen in previous studies. This has led some researchers to conclude that the dark stream is more than just a statistical phenomenon caused by sudden changes in the CMB. Proponents of the current dark theory, however, argue that Planck's data do not conclusively disprove its existence. They point out that the Planck satellite is not specifically designed to study the dark stream, and the data may not be sensitive enough to detect the phenomenon. In addition, the dark stream was observed in a specific region of the sky, and it is possible that Planck's light did not cover this region in sufficient detail. The current dark debate continues, with researchers on both sides of the issue coming up with new evidence and explanations. What is clear is that this phenomenon, if it exists, can provide important insights into the nature of the universe and the forces that shape it. If the dark current is real, it shows that the world is more interconnected than we previously thought. This shows that there are places out there that we can't see, but we can still see their influence. This raises the possibility that there are other worlds, other forms, or other forces pulling the strings behind the celestial veil. The discovery of a dark stream, in which clusters of galaxies move in the same direction, defies conventional explanations and reveals the influence of an invisible force outside the visible universe. The dark river appears to have been created by a large structure or another world, raising questions about the size and complexity of the universe. Evidence from WMAP and subsequent studies indicate that many galaxy clusters are associated with the dark stream, adding to this mysterious phenomenon. The connection between dark currents, cosmic inflation and string theory points to the existence of multidimensional or higher-dimensional space. Controversy surrounds the dark current, with critics rejecting more conventional explanations and Planck satellite data challenging its existence. The debate over the existence and effects of the dark current continues, with scientists on both sides presenting new evidence.